getting it into the form. All right, the biggest problem people seem to be having with this is how in the world do you end up with 19 pi over 12? When we did our problem in class, we got to use the nice easy stuff in quadrant 1. Unfortunately, to get to 19 pi over 12, we have to move out of quadrant 1 and into quadrant, I have no idea where I ended up. But after somebody asked, I figured it out. He asked first, so I figured it out, and I just copied and sent it to you. So, moving out of quadrant 1, what do we know? Because obviously quadrant 1 is not overly helpful. I think we get to use part of it. So, out of quadrant 1, let's move into quadrant 2. What angles in quadrant 2 do we know? We know 2 pi over 3. What else do we know? 3 pi over 4. 5 pi over 6. So let's see how these look in terms of 12s. In terms of 12, this is 8 pi over 12. This would be 9 pi over 12. And this would be 10 pi over 12. That's supposed to be a 12 there. Looking ahead and missed it. Over 12. All right. Hey, I got 2 that I can add together. Thank goodness. It may not be the same 2 that I told you guys, but it doesn't matter which 2. You end up in the same place. So I can do this as a cosine. No, it's sine. Sine of 9 pi over 12 plus 10 pi over 12. Which is going to be the sine of, well, 3 pi over 4 plus 5 pi over 6. Now, using the formula, what does this come out to be? Well, it's the sine of the first angle, right? So sine of 3 pi over 4 times the cosine of the second angle, so cosine of 5 pi over 6. In sine, if it's plus, then the formula is plus. And then it's the sine of the second angle, so the sine of 5 pi over 6, times the cosine of the first angle, which was 3 pi over 4. All right, what's the sine of 3 pi over 4? So it's related to the square root of 2 over 2. Is it going to be positive or negative? In quadrant 2, sine is, because this is a quadrant 2 angle, positive, so that gets to be positive. What's the cosine of 5 pi over 6? Brad, what? No. This one? No. This one? No, because that's a 6, so it's not going to be over square root of 2.
Oh, yeah.
Square root of 3 over 2, excuse me, and it's going to be negative because in the quadrant 2 the cosine is negative. Then plus. Sine of 5 pi over 6, well, that must be the 1/2. Right? And the cosine of the square root of 3 pi over 4 is the negative square root of 2 over 2 because cosine is negative in quadrant 2. So then what do I have? Well, I have the square root of 2, well, the negative square root of 2 times the square root of 3 plus, okay, minus, do I need a plus in here? We'll do minus. Minus the square root of 2 all over 4. But what I need is I need to pull out a negative sign. 2 times 2. I need to pull out a negative sign and a square root of something. Well, what square root is in both spots? 2, and the negative sign is in both spots, so I can factor out the negative and the square root of 2. When I factor out the square root of 2 from the square root of 2 times the square root of 3, I'm left with the square root of 3. When I factor out the square root of 2 from the square root of 2, I'm left with 1, and it's going to be plus because I pulled out the negative sign too. And then that's going to be over 4. So, does that fit with this setup? It's got a negative out front. Yep. It's got a square root of number. Yep. Times the square root of another number plus 1. Yep. All divided by 4. Got it. A must be 2, B must be 3.